I assume. And we talk about the first 8 functions in basic 1. This table, okay, and the contents related to this table is the singular most important point we start, okay? And we're going to summarize about these 8 functions at the beginning of this class. Let's see, to pull out your notes and pull out whatever you have studied, okay? And you're going to see a quiz about these functions. Okay, you're going to see a quiz about these functions. But anyway, so let's get started, okay? Summary. So what are we going to summarize about these functions, right? So what have we studied about these functions? The meaning, right? The meaning. We talk about the function, the constant function, right? The first one, what it means, right? For any input, the output is always the same. Number 2, domain and range, right? We plotted the points, and we know that we did the curve, right? We did the curve. Number 3, so this, number 2, number 3, number 4, right? What was number 4? Number 4 was x squared, I believe, right? There. Okay, the rule, we talk about the rule, and we did the graph. Let me make it just a little smaller so we can see everything, okay? So these are the 8 functions. Number 5, right? The square root of function, domain and range intercepts, and we studied it. We study it. Number 6. Number 6 is a very, very important function. You're gonna encounter all of these functions in calculus classes. And right now we're gonna review one by one, and we're gonna see the variation of them. We will see the variation of them throughout the semester, okay? And of course, we still have more to go. We're not even reached the half point, right? Number 7, okay? We did number 7 and number 8. Number 7, number 8. Okay, so among all of these functions that we covered in the recording, okay, we covered in the recording. If you haven't watched it, please go back to watch it. All these details, we did all these detailed work. Very, very important that you know how to do it. It's very easy to do, I promise you, but it is also very easy not to do. And this part of the graphing is called analytical geometry. Analytical geometry. So I'm going to put it together to summarize this. Okay, so I'm going to summarize all these different points. Okay, different points. First of all, okay, and of course, the first function we're going to talk about is y equals to the constant. Okay, and in our example, we said y equals to 2 or whatever, right? And we talk about domain, range. So what I'm showing you here is how to study. Okay, so when you study, right? When you're taking this class, or you're going to take the next class, right? You must learn how to summarize. Okay, in here, intercept, x-intercept, I'm going to put a possibly plural, and y-intercept is a singular. And I want you guys to think about why. Why the x-intercept could be plural and y-intercept must be singular. Okay, so leave that question. And of course, the domain. Anybody want to contribute about the domain of the constant function? Well, I know you guys just filing in, right? From negative infinity to positive infinity, and the range is just a constant itself. Okay, this is it's very important function you get to learn. X-intercept. Okay, if C is not 0, none, unless C is 0. What happens if C is 0? Well, that becomes x-axis, right? In that case, it's it's overlap. Okay, so y-intercept. Y-intercept is 0, C, 0, C. So we went over this, right? The second function in that study is that y equals to 1 over x. 1 over x. Okay, 1 over x. Domain range graph. I think we should put a column to put a graph, right? We can put a column with a graph. So let me insert a column. It's not about memorization, guys. You guys must understand this is not about memorization. Okay, insert column. Okay, so I'm going to put it here. Wait. No, I just put it here. The graph, right? So I'm going to also take this opportunity just to I hope all of you have watched this video, okay, which is in the recording, right? You can see the graph tells us domain range, intercepts, and x-intercept, y-intercept. The second one, this function, okay, all of this function, every function here we discussed, you're going to see them again in calculus. Okay, so this part we did is analytical geometry. This is called analytical geometry, right? So we call it graph. Okay, graph is analytical geometry. So we have to know the details about it. So y equals to 1 over x, or what is that graph? We did that graph. Okay. Copy and paste. So this is how you do summary. This is how you do summary. Of course, there's certain things, certain details been missed, is not here because we didn't show the plotting points. Okay, so you must watch that piece of video, the recording that we did last week. And the domain, what is the domain here? Domain is that x cannot be 0, right? X cannot be 0. And the range, 1 over x cannot be 0 either. Okay, so for this particular function, intercept, none. Okay. So the goal for me is to encourage you guys, hopefully, to have done all of these graphs all by yourself. The keyword is all by yourself. You don't just watch me doing it. You have to do it by yourself. And this lays the foundation for you. This lays a good foundation for you in the next class. So that's y equals to 1 over x. I also show you how to summarize. Okay, how to put summaries together. Okay, this is a good habit. When did I learn this? When I was in high school, I met this teacher and he was showing me how he mentioned this study method. You summarize, okay? You summarize chapter by chapter, but you also summarize across the chapters. Okay, what does it mean by summarizing across chapters? Because different functions, they have similar features. So this is what we're doing here, is summarizing across chapters. Okay, is everybody here? All right, summarizing across chapters, because if you look at any particular textbook, it's most likely that these functions are covered in different chapters. And you bring them all together. This is a cross-chapter summary. Okay, very, very important. Okay, it's not only the knowledge, it's also the method of study. Okay, it's also the method of study. That's the second function. Okay, the third function. Okay, the third function. If you guys have any questions, please don't hesitate. I will give you time to ask questions. Okay, the third function is y equals to x. Where is it? We did it, right? This is number 2. Number 3. Number 3. Right, see, we plotted all these points. Number 3, we talk about this function is just about, the output is the same as the input. Whatever input you give me, I get the output exactly the same as input, okay? So this function that we did it over here, we plot the points, x-intercept, y-intercepts, and we're about to introduce some new concept. So this is y equals to x, okay? So I'm gonna put that I put that notation, very useful notation for in your summary, okay? So we want to get you used to using this new notation, okay? So this is number 3. Number 3 function is that meaning the input is the same as the output. Okay, so this tells us the rule is that the input is x, the output is also x. Okay, so how does the curve look like? How does the graph look like? Right here. We summarized right here. And I'm just going to make it a little smaller. This is something you can totally do, right? Right? You guys can totally do this. Now, domain range. Domain obviously is all real numbers. And the range is also the same, all real numbers, because whatever is from the domain is going to be in the range. Okay. And the intercept, we have 0, 0, 0, 0. Okay. I shall put the rules in there if you like. You see, when we summarize, right? When we summarize, it's a process that you process the information. Right? So we process the information. Along the way, we're adding, subtracting the necessary points, right? We're adding, subtracting the necessary points. Let me do this. Hold on. It's just a little bit, the program is a little bit naughty because when I try to insert one more column, it doesn't show the, it doesn't allow me to do the highlight. So this way, I'm going to do that. Okay, just give me a second to get this done correctly. Okay, so you can see the process. I do the summary. And this typically is expected of you as a student to do it. Okay. Once you go to 4-year schools, your professor's not going to do that for you. You have to do it. You have to learn how to do it. Okay. So I hope my learning experience will be of some benefit to you. Okay. So now we have done number 3, function number 3, which is the reason I added this new column is to show you how the rule works, because we talk about function is a rule, right? And this rule takes the input and produces output. It takes input, produces output. So what is the rule? And this is the rule. Every input, right, is made to produce an output, and the output is always the same for the first function. And for the second one, right, you give me any input, I'm producing the reciprocal of the input, and that's going to produce the output, right? So that's the rule. That's the rule. Okay. So let me make this jet. I know the board is not large enough. Okay. So hopefully this is better. Do you guys see well? Does everybody see well? Okay. So what we're summarizing. And the next one, okay, given input, we produces the output. And the rule of this output producing process, you can see the rules are different, but the ideas, the method of studying are the same, aren't they? We study these different aspects, right? Now, the next one, function number 4. What is function number 4? The square function. Okay, y equals to, yes.
Professor, is it good idea to put the f of x equals absolute value of x here so we can compare the graphically what is the difference between f of x equal x and f of x equal absolute value of x, maybe?
Yeah, sure. You mean right underneath it?
No, instead of x squared. That way we can compare, you see, f of x equal x, the graph of it, and the absolute value of x. Just visually, it can make sense. The concept you were bringing up last week, when the absolute value of x is equals x, negative x, for what values, negative, positive, all those things.
They're all going to be in this table.
Right.
Right?
Yes. So I didn't want to distract your concentration. Sorry about that. But
no, it's okay. You mean to, because you're gonna see all of these graphs here.
Right. But you see, you started for f of x, x squared. Instead of x squared, could we put the absolute value of x and then x squared next line?
So you mean to put it here?
Yes.
Sure, we can do that. Okay. So these are the rules. You can see all these are different rules, right? And this rule with x squared is saying, okay, given me the input, the output is going to be, I take the input and multiply the input itself and produce this output. And the graph, okay, so here's the graph. So here's the graph. Okay, so here's the graph. So domain range, we talk about domain is from negative infinity to positive infinity. And the range, what is the range? Could anybody contribute on this part? I would like to see some interaction. Did you guys watch the recording? Right? Did you guys watch the recording? There's a preferred way of expressing the range here. Anybody? Yeah? Nobody said anything.
I would be the last to answer.
Well, that shows that some of you may not have watched the recording or you haven't I will quiz you, okay? You're gonna see a quiz today. It's very important that you keep up with me. It's very important you keep up with me. If you don't keep up with me, if you don't do the work, and you will be lost at a certain point. You'll be lost at a certain point. Okay, and I don't want that to happen to you. So 0, 0. So I'm just going to put it here. I'm not going to investigate if you, who has watched, who has not watched. Okay, and you're going to see these on quizzes, and you will see these in your calculus class. Okay, you see these in your calculus class. The absolute value x, and I'm gonna go by Farou's recommendation. So the absolute value, okay, this is the graph. Okay, don't think that if you're attending today's class, I'm doing the summary, then you don't need to watch the recording. Okay, you need to, because in that recording, there's so much more details that we all need to know, especially you. Okay, especially you. All right. So from negative infinity to positive infinity. This is not about memorization, guys. This is, I cannot emphasize enough that this is not about memorization. Some people say, oh, I just remember these. And, you know, I have this amazing memory, then I'm going to memorize this. Okay, for example, in the recording last week, last Thursday for the second, there's a one sentence domain range. We're going to use that all the time. We're going to use that all the time. Okay, so please do watch those recordings. Okay, now, so this is the absolute value of x. Okay, so we have 3 more to go. Okay, we have 3 more to go. And the next one is, I would say, square root of x. Okay, f of x. Right after this, we're going to introduce some other new concept, very important concept. Okay, so don't go away and please participate. Please participate. Now, so I've covered all these functions. Let's see, this space seems to be so much larger than I want it to be, right? But anyway, the absolute value of x, right? So the rule for absolute value of x is that you have an input, and we have a rule, and the rule of this function, a function is a rule, right? A function is a rule. I keep mentioning that a concept. You probably hear this many, many times, and you need to have that concept running in your blood. Because you hear me saying it over and over again, and that should be part of your language as well. So domain, okay, this domain I'm going to use inequality notation. Okay, and the range, I'm also going to use inequality notation. All these are preferred notation. Okay, and of course here the x-intercept, y-intercept are the same. And the last 2 functions, one is y equals to x raised to the power 3, such a simple function. And you will find it used in calculus class again on a different setting. Okay, so you need to know the graph. You need to know the graph. Okay, so x is the input. It produces an output by the rule of, okay, so this rule says you take the input, okay, I multiply the input with itself 3 times, it produces the output. And the next one is the cubic root function. Okay, you guys have done 34A, right? Did you see the neighborhood of 34A in the notes? Or you just, did you look at the exercises in the neighborhood of that? You think you might need to, do you know how to do them? Right? But anyway, so all these details, right? So these rules and this rule is you take the input and we take a cubic root of it and then produces an output. Okay, so let's look at these graphs. Let's look at these graphs. Okay, on the 2nd, okay, September the 2nd, we did, oh, okay, hold on, I think I'm running too fast, right? So this is x raised to the power 3. That's the graph. Hold on. There. Okay, this is x raised to the power 3. And let's do the cubic root. The cubic root. One more right here. The cubic root. Okay. The cubic root. Okay. So what happened? What is the domain and range? What is the domain and range? The domain and range from negative infinity to positive infinity, and the range are the same. Okay. Domain, range, they're all the same. Now, intercepts, they're all the same. Okay, so we need to understand what they means, right? So this is a summary of what was done in on the 9th on the recording. Okay, everybody need to know how to do it by yourself. Okay, and I will have a homework exercise to give it to you, which is basic 33. Basic 33. Okay, if you know everything we have covered so far, if you know that all these operations, right? All these operations we did, then you should know how to do basic 33. You should know how to basic 33. Okay, so that will be in today's homework. So that was a summary. Did I miss a picture here? Yes, I didn't miss the picture. So this is how to do summary. As a student, you must know how to do summary. You summarize every chapter you learn, and then you also summarize, across the chapters at the end of the semester. If you do this, you will always do well. You always do well, no matter what subject you study. No matter what subject you study. Okay, this is the method I learned when I was in high school. And but of course, it needs practice, right? It needs practice. At the beginning, I wouldn't know what to do. I said, what I'm going to look for to summarize. Over time, you realize, this is what's important. And in this section, we already told you what's important. Okay, we already told you what's important, right? Domain, range, intercepts, and the meaning of the rule, how to produce the rule. Now, without further ado, we said we're going to introduce new concepts. And before we talk about what a function is, right? A function is a function. A function is a rule that assigns to each element x in a set of A exactly one element called f of x in a set of B. So this is the definition of function. And today we're going to introduce one-to-one function. One-to-one function. What is one-to-one function? I want everybody to put that on your flashcard. Okay, so please grab your flashcard or notebook. Write down what is a one-to-one function. What is one-to-one function? Over the weekend, I read your bio. Thank you for your contribution. That was very fun to read them, okay? Now, a function with domain A is called a one-to-one function if no two elements of A have the same image, that is, okay? I'm gonna do some explanation. Okay? Meanwhile, I'm gonna do some conversions of this, the writing, okay? It's not no mathematical notation is not proper. So I just do a little conversion, whatever. What it means. What does it mean? Okay, if you look at these two definitions, the first one tells us what is a function. The second one tells us, it says a function. So it's provided that we have a function already, i.e. we only consider whether a function is one-to-one if we have determined it is a function. Okay, it is a function. In your previous learning experience, have you learned something called a vertical line test?
Yes.
What is it?
It's when you test a line and see if it's vertical or if it passes the vertical test at all.
Okay, so why vertical line test? Vertical line test basically is another way of saying the definition of function. Okay, for each element X, there's a unique output. So the vertical line test is about what? So let's look at what we just summarized. Okay, let's look at what we have just summarized. The first function. Okay, I want you guys to have your definition of function next to you. Okay, to go over vertical line test. Vertical line test says you just draw vertical lines arbitrarily. Each time you hit the curve exactly at exactly one point. What does it say? What does that mean? Suppose I look at this line. Vertical lines test is saying you draw a vertical line arbitrarily. When you draw that vertical line, you're going to hit a place called input. And you also hit a place with the curve right here. So for each input, which is the heart, we have exactly one output. So vertical line test basically is a graphical description of the definition of function. Do you follow me? Because for each input, there's exactly one output, which is exactly the definition, right? Now, let's look at the second one. Let's look at the second one. Does this one pass the vertical line test? You draw arbitrarily a vertical line. You get an input. The input, oops, that's too big, right? That's too big. So I'm going to remove that. The input is right here, right? This dot with the crossing. For each input, there's exactly one output. So what is the output? The input is a horizontal and the output is the vertical, right? The output is a vertical. So in this case, let me make the picture just a little bit larger to illustrate. Okay, and I want you guys to have your eyes on. I'm really basically showing you how to study calculus class. Okay, so for each input, okay, you draw that vertical line. In calculus class, you're gonna have a new concept, right? You're gonna learn new concept. So, excuse me. This vertical line you draw crosses the curve excuse me, at exactly 1 point, no more than 1 point. Okay, the actual statement is saying no more than 1 point. Why no more than 1? It could be 0. You may not touch it. If you don't touch it at those places you don't touch it, those places you should not have a domain. Okay, so to be a function for each point you touched, you should have exactly, so this is the input, right? This is the input. Let me make a different color. That's the input. Okay, so what is the actual value of the input? The actual value of the input, this is the input. And what is the output? Okay, I'm going to erase this line and put the output. So what is the output? Right, the output is the vertical line right here. So vertical line test is drawing this vertical line to hit a point where you both have the input and exactly one output. So that's the meaning of vertical line test. Okay, and be careful, you draw vertical line arbitrarily, okay? Now, so let's examine all the other functions in here. Everyone passes a vertical line test, right? This one passes a vertical line test, we know that. And this one passes a vertical line test, right? This one passes a vertical line test. By the way, when I was lecturing on the absolute value function in the recording, I spent a lot of time, there are a lot of important details everyone must know to ensure you get that 20 points in calculus class, okay? If you simply just remember this, you know, how the curve is, how the curve look like, you can draw that V, that's not enough. I assure you it's not enough, okay? You need the details I went over in that class in a recording, okay? Because we are shooting for the best possible understanding of it. Okay, so all of these passes vertical line test, including all of these functions, right? All of these. So now we come back to this definition. A function is a rule that assigns to each element X in the set of A exactly one element called f of X in the set of B. So now we know that a vertical line test is just a graphical method to test whether a graph is a function. Now let's look at one-to-one function. One-to-one function is based on you already have a function, because if you don't have a function, we don't even talk about one-to-one. There's no need to talk about it. So we start with a function. Okay, what does it mean? If we are dealing with a function, that means this entire definition already applied, right? It's already applied. So a function with domain A is called a one-to-one function. Okay, so a function f, I can just put a symbol here, f, with domain A is called a one-to-one function if, okay, no two elements of A have the same image. What is image? Image really means outputs. If we refer to the elements of A as inputs, okay, so these are the interpretations I wish you to understand. What does it mean? Okay, I want you guys to chew on these words, really try to understand it, okay? Really try to understand it. Because this is the method you're going to study in calculus classes. Now, we talk about that function has, well, function is a rule, right? This is the function. Function is a rule. But you may have, and this one-to-one function says, well, that's not enough. That's not enough. We also want to make sure when the input, whenever inputs are different, okay, so these two inputs, whenever the inputs are different, okay, so for that rule, okay, we have the rule here. Okay, each time with different input, we produces an output. For input 1, we produce output f of x1. So whenever the input are different, their outputs are not the same either. And this is certainly a stronger requirement than the previous situation, right? For example, for a function to qualify to be a function, right? We didn't ask you to have different input produces different output. Why? For example, the first function, the constant function, it produces the same output for all of the input. Every input, you produce the same output. Every input, right? So for each input, I have an input here, and I have another input over here. These are different input, but they produce the same output. The same outputs are, there's output here, same height, and this is output over here. Different input produces the same output, and that will still make it a function because it is still true for each input. There's a unique output, and that unique output is the constant C, which is all the same for any input, right? So by, okay, I see a message on chat. I'm sorry, I am really late. Our internet was down. Okay, that's okay. Welcome to the class, and you get to watch the recording, okay? Thank you. All right, so now look at this. Look at the second function, because now we are going to examine among all of these 8 functions, which one is one-to-one, which one is not one-to-one. Okay, which one is one-to-one, which one is not one-to-one. Okay, so did you write down the definition of one-to-one function on the flashcard? Because I want it to be next to you. Definition of one-to-one function. Whenever the inputs are different and the outputs are different are different too. Okay, image means output. You're gonna see this word used here and there because some math authors, they like to use image, but image is really the outputs. Okay, did you guys write it down? So whenever, okay, whenever. So what does it mean? What does it mean by whenever? For all of them, for any different, okay? So in other words, I'm going to give you another word. In other words, for any x1, x2 that are not the same, their output are not the same too. Okay, their output are not the same as well. Okay, so let's use this definition to examine all of these 8 functions we just studied, right? So obviously this is not a one-to-one, right? This is not a one-to-one. Okay, so I'm going to mark here. This is not one-to-one.
Professor,
Yes.
this function, I see it is not a function, one-to-one function, but it passed the vertical line test, doesn't it?
It passed the vertical line test. It is a function, but it doesn't fit the one-to-one function definition.
Yes, thanks.
For one-to-one function, and of course, we're going to talk about horizontal line test. Okay, we're going to talk about horizontal line test. But right now, I want you guys to focus on the words. Okay? So have your card next to you. Have your card next to you. So the first function is not one-to-one. Any questions, you guys?
Thank you, Professor.
No problem. I know it's very hard to concentrate in this case because I cannot see you. I cannot see your expressions on your face, especially you. But I also want you to see that this method I'm teaching you is really the method I want to show you, that you need to take this method to study your calculus class. That's the lesson I have learned. As you know, I remember on the first day and the first week, someone asked me what was the roadblock I met when I was studying calculus. Is the method of study. It's a method of study. In algebra class, you can just keep going, right? You don't have to think too much after you master the principles. But in calculus class, you really have to study the words. You have to think about, reflect on the meaning of the words. So I'm showing you, even though we're not covering the same concept, I'm showing you the method of study. All right, so let's look at this function.
Jacob raised hand.
Thank you, Jacob. Let's see which. Okay, Jacob, go ahead.
Do you think you can explain why the first one is not a one-to-one again?
I can explain it again.
Do you think you can explain one more time?
Sure. Okay. Why the first one is not a one-to-one? Right? First of all, it is a function, right? So I'm going to take this function and I'm going to explain it to you right here. It is this function, it is a function, right?
Yes.
Because why it is a function? Well, you can say it passes the vertical line test. But if I use the word, I can say, then I'm going to quote the function definition. Okay. You will find that in your calculus class, if you learn how to quote the definition, you're going to get a lot of points if you know how to quote them. Okay, I'm showing you how to do that. Okay. Why it is a function? Because for each, you see, I'm quoting the function because for each element, X in the domain, okay, this is a function specific, right? So I'm going to I'm going to make the specific for each element X in the domain. I quoted the domain for this function. The output, okay, there is exactly, okay, I'm quoting exactly one value for f of x for the output. Okay, so it is a function. Why it is not a function? Okay. I'm gonna bring this one over here. I'll just put it here. But it is not a one-to-one function. Okay, I'm gonna write down the reasons for you, okay? When I'm saying it's not a one-to-one function, I'm going to quote the definition of one-to-one and its opposite. Okay, I'm going to quote the definition of one-to-one. So for each definition, it tells you what is, it also tells us what is not. You guys follow me? For each definition, it tells us both what is, it also tells us what is not. Okay, so now it tells us what is, right? What is whenever that is. This is the is one-to-one. What to make it is not. In your calculus class, you need to figure out, okay, it tells me it is a limit, but it also tells you when it is not a limit. It is a continuous, when it is not a continuous. It is a differentiable. It also tells you what is not a differentiable. You guys see how this technique is going to apply? So please pay attention to what I said here, okay? It also, what's the opposite? What is the opposite of it is not a one-to-one function? Right?
Will the opposite be if f of x was to equal f of x2? That'd be the opposite.
That's a good one, but it's not finished. For what kind of x1, x2? Do we still use whenever? It is, right? That's a very good point, Jacob. But you're not finished. You have to tell me what x1, x2 must be. Because here it tells you is one-to-one if whenever x1, x2 are not the same, f of x1 and f of x2 are not the same. And there's a key word here called whenever. Whenever basically say any x1, x2, arbitrarily x1, x2, when they're not the same, then their outputs are not the same. But what will be the opposite of it? The opposite of it, what's the opposite of whenever? What's the opposite of whenever?
Never.
Never?
Only and only if.
Whenever. And we have option 1. What did you say, Karuz?
He said only and only if.
Only if,
Only,
only and only if.
yes.
Okay, so what's the opposite of whenever? We have C. Never, right? Someone said never. What is the opposite of whenever? Oh, sorry. The opposite of whenever. This is A, and this is B. We have a C. Is never the opposite of whenever? Haha, this requires some logic, right? This requires some logic. Is never the opposite of whenever. It's a part of it. It's a part of it. It's not all of it. Okay. The opposite of whenever is for some x1 not equals to x2. So it's not 1-to-1. Okay. It's not never. Never could be a case, but it could be for some. So it could be for some x1 not equals to x2. The output are not the same, but for some x1, x2 that are not the same, their output are the same. But how many such counterexamples do we need? This go back to the beginning of the semester. I talk about that if true, always true, false once, false. In fact, you only need one pair. You only need one pair. I want you guys, are you guys with me? We're really chewing on the words, but this is what you're going to do all day long in Cal. A lot of us are not used to it, including myself. When I enter calculus class, I was totally lost because I didn't know how to study. It required me to, well, by the way, I was a math major. It required me to think about these words and differentiate the meaning of words in order to understand things. And this is something most of us are not used to. Okay, so it takes some training, but enough training will get you there. Okay, this is, everybody can get this. Okay, so the opposite of whenever includes never. Why includes never, but not limited to never? Why? Because never you will mean that for any x1, x2. So what would be never means in mathematical context in this situation? What would never means? Does it mean for any x1, x2, then f of x1 equals x2? That's one situation. That's one situation, right? Which is a constant case. In the constant case, for any x1, x2, f of x1 is equals to f of x2. They're always the same. So this will be the never case. But it is not a limit to. So let's see only and only if. I'm not sure how I can interpret this. Farouz, do you want to interpret this somehow?
Yes, Professor, probably just confirming what you said, only and only if we find only one exception, one false, then that is going to be false. Only and only if one exception, then the function is not one-to-one.
Then you cannot use only and only if, because we don't have such a phrase. Okay.
Sure.
You just have to say for some x1 equals to, not equals to x2, but their output are the same.
Right. That is easier. Thank you, sir. Thank you, ma'am.
Mhm. Yes. How about, did everybody get this? It requires a lot of thinking, isn't it? So the opposite of whenever is for some. Okay, so now let's illustrate why it is not a one-to-one. Okay, so let's see how we put the words together. Okay, how to make the statement to on this function is not a one-to-one function. How to make the statement on f of x equals to c is not a one-to-one function. This is how you can do it. Okay, once you understand this, right, what's the opposite? Okay, you will say for, right, for some x1, x2 in A, of course they must be in A, right? They must be in A. So I would say for x1 equals to 1, x2 equals to 3, but f of x1 is equals to c equals to f of x2. Do you follow me? So these are the words you can use. These are the examples. Of course, you don't have to choose 1 and 2. You may have other examples. Does everybody get this part?
Mm-hmm.
Thank you. Okay, thank you for the feedback. Now, let's look at the next function. Let's look at the next function. Okay, the next function we study is this function 1-to-1. The 1-to-1 function basically is saying if I swap the input output, okay, if I swap the input output, it still makes a function. That's really what it is. Okay, whenever the input are different, the output are different. In other words, if that is the case, if the outputs are different, then the input must be different. Do you follow me? So if inputs are different, outputs are also different. That implies that if we know the outputs are different, then we can infer the outputs are not the same either. Okay, so for example, this would derive the horizontal line test. The horizontal line test. So from horizontal line test, this passes a horizontal line test. Did you guys learn about horizontal line test before? So if we do the vertical line test, right, arbitrarily draw the vertical line. We cross the curve no more than once. That's a vertical line test. And we can also draw the horizontal line test. What does this mean? Right? When we draw the horizontal line test, it means that when the output, okay, when the output is different, so I draw two horizontal line tests, different horizontal line tests, and this will give me different outputs. And for different outputs, there are different inputs. So if the horizontal line test is passed, it is a one-to-one function. So this function is a one-to-one function. But how do I say it using words? Okay, we know the graph. You guys learned the graph, the graphical method before, but now to prepare you better for your calculus class, you need to be able to use words. All right, so how do I explain this function is one-to-one function, right? So I'm going to put it here. How do I state that is a one-to-one function? Okay, you're going to quote the definition. Quote the definition. I'm going to show you how you quote the definition. Quote the definition. Quote the definition. Okay, what is the essence in that definition? You'll say, whenever x1 is not the same as x2 in this case, and they're in the domain, of course, okay, in the domain of that function. The domain of that function implies that x1, x2, you know, they cannot be zero, right? What's the domain of that function? X cannot be zero, right? X cannot be zero. You see, I'm quoting the definition. I'm quoting the definition. So whenever x1, x2 are not the same, 1 over x1 is not going to be the same. The reciprocal are not going to be the same. Thus is a one-to-one function. That's how you say it. Is there any other way to say it? I'm sure there are other ways to do it, to say it. But you say something like this along this line, you're quoting the definition. To be successful in calculus class, you must know how to quote the definition to the point, I mean correctly. Oftentimes, quoting a definition is not just a copy of the definition. You need to apply the definition in certain pieces in the right place. You follow me? All right. Okay, so this is a one-to-one function, right? This is a one-to-one function. And next, let's look at the third one. We got the second one. Let's look at the third one. Is this function a one-to-one function? Okay, so let me make a little distinction. So this is the number 2 function, right? Number 1 function. Okay, obviously the summary about one-to-one function is not in that table, and you may like to put it there. Okay, you may like to put it there. Is f of x equal x squared a one-to-one function? Okay, so let's bring the definition of function with us. Okay, let's bring the definition of function with us. So I'm going to clean this up. Everybody, I know this has been, I think, somewhat intense if you try to engage in the discussion. To be or not to be, right? To be or not to be. I'm going to say, I'm going to copy this piece as too. Is not. And we also say to be not to be. So now the question is f of x equals x squared a one-to-one function? And how do you make that statement? Right? In calculus class, I often see some students say, I know it, but I just can't say it. Don't know how to say it. Did I have similar experience before? Of course I did. You knew, sometimes you have some intuitions. I said, I think it's not, or I think it is, but I just don't know how to say it. And you have to say, you have to be able to say it correctly to get those points. So I see mathematical training. It's not about numbers. It's about thinking. How to think logically. All right. Anybody have any comments? Well, if otherwise, I'm gonna continue. Okay. You have to do a lot of thinking homework. Okay, which is hard for me to go to your mind to see what you're thinking, but you'll be quizzed on them. You'll be quizzed on them. Okay. Now, to be, it has to be whenever, not to be for some. Okay, for some. If you do the vertical line test, it certainly passed the vertical line test. It is a function. So we can in turn consider whether it's a one-to-one function. But if we do the horizontal line test, it does not pass the horizontal line test. Yes? Does everybody follow me?
Yes.
It doesn't pass the horizontal line test. In the past, your professor probably would say, oh, it doesn't pass the horizontal line test, therefore it's not a one-to-one, and you're done. And that's not enough when you do calculus. You can't do it. You can't say, oh, because there's a hole, therefore it's not continuous. Then your calculus professor will say, what hole? You get 0. You can't say that. You have to use the language of mathematics to say it and how to, right? So you don't know the answer. You just, how do we say it? This is how. Okay, so let me show you. Okay. All I have to do is just to tell the reader for some. Okay. For x1 equals to 1, x sub 2 equals to -1. They are in the domain, right? Because the domain for x squared is all real numbers. So you can also go ahead and say, in the domain of the set function, in the domain of the function. And what is more, you're going to point it out to the reader that x1 is not the same of x2. Okay. Isn't that obvious? But sometimes you make a point by pointing out the most obvious. Okay, x1 is not x2. Why do I do that? Because I want to talk about, I want to relate to something in the definition. Okay, I have a pair of x1 that's not equals to x2. And here they are. I even tell you what the values. But the output 1 squared is the same as -1 squared. I don't need the parentheses. That is, i.e., okay, f of x1 is equal to f of x2. You certainly can make it simple. Okay, you can make it much simpler than that. I'm going to give you another version of it. I'm going to give you another version of it. Okay, I'm going to make it much simpler. I want you guys to see the variety of ways you can say it. You can say, oh, 1 is not equals to, you can even omit those, x1, x2. But f of 1 it can be as long as this guy, it can be as short as this one. But you all point to the same place. You point to the definition, which is for some x1 not equals to x2, f of x1 is the same as f of x2, which is not to be. Does everybody follow me? Isn't that interesting? Isn't that interesting?
Professor, that's what I see, the language of calculus. You're trying to help us to learn that before calculus.
Yes. Thank you for that insight. I'm training you. I'm really trying to get you guys ready for calculus. This is how you study calculus. Once you get a hang of it, you're going to be liberated. You're going to get an ace. If you don't, it's a struggle. Of course, this is the wording part. This is the wording part. There's also the algebraic part, okay, which you need a lot of practice, right? If you walk into a calculus class, you in a lot of those days, many of those days, Calc 1, Calc 2, you will see the board is covered by algebra. Because without proper algebra, you cannot possibly do calculus. So you need a strong algebra, and you need to know how to dissect definition. You need to know how to determine to be and not to be. And what is a condition and what's a conclusion? All right, so write that down, and our time is fleeting, right? So this is how we illustrate f of x equals to x squared is not a one-to-one function. It's not a one-to-one function, okay? This is a very important concept, but we use this concept to illustrate to you how you study calculus classes. And of course, this concept itself is very important also. So let's look at the next function, right? So we did x squares. I'm not going to do all the examples, but I certainly would do this one, okay? And this one, I'm going to give you an opportunity to try it. Is this function one-to-one? Okay, so you have the example above. Right? So here's the question. Is the absolute value function one-to-one? Remember earlier on when I was making that table, Farouz suggested that I put these two functions together. There's certainly a lot of interesting similarities, even though they're not the same function. So now these two functions are together again. Okay, you can do your vertical line test, the horizontal line test to confirm or give you some insight about these properties. But how do you say it? How do you say it using the words, using the language of mathematics? Hi, everyone. I will be in MCS. Okay, thank you, Farouz.
You're welcome. Because yesterday was a Labor Day, so I shift my schedule from yesterday to today with my supervisor approval, so I can help the students in case if they need help.
Thank you so much.
You're welcome.
All right, guys. Is this function one-to-one? You can use exactly the same wording here. It's just a different rule. Okay. For some, therefore, this function is what? Is not one-to-one. And of course, here, the function is not a one-to-one. All right. You guys okay with, did you guys have a chance to write it down, to take the notes? Right? So x squared is not a one-to-one. It is a function, but it's not a one-to-one. And how do you say it's not a one-to-one? Here you got the tools, right? You can use your own language, but it has to be along the line of definition. You quote the definition, but not a strict copy of the definition. You pick up the necessary part for us to illustrate, to make our point. Okay, we still have some time. So my intention is to cover all of these important functions. For example, how about x raised to the power 3? Are these two functions one-to-one? Is this function one-to-one? If you do your vertical line test, the horizontal line test, what do you get? Right? Is this function one-to-one? If it is, you use one word. You use one sentence structure. If it's not to be, you use another one. This function is one-to-one. And then what kind of wording you're going to use? In that case, you're not going to use the examples because the example only give you anecdotes. You cannot use anecdotes. You have to use the full sentence in its context. But so you're quoting the definition, but not without changing, without it, you're quoting the definition, but you have to make some changes, make some necessary changes. So what will be the necessary changes here? So here you can say x1 to the power 3, x2 raised to the power 3, in the domain, which is from negative infinity to positive infinity. Okay, so the answer is yes. It is 1-to-1. Okay, so let me put it down here. It is 1-to-1 because the output, whenever the input are different, the output are different. You're gonna insert the specific functions rule. For x raised to power, for the cubic root of for the cubic root of x, that's also 1-to-1 function. I'm going to leave that for you. Last but not least, the square root function. Okay, the square root function. Where's my square root function? Right here. Is this function 1-to-1? Is this function 1-to-1? Is this function 1-to-1?
It is a 1-to-1 function.
Say it again.
It is.
And very good. The answer is right. But how do you make it? How do you make that perfect statement?
You would say, can you give me a second to think it out?
You can type it on chat. Try it. You guys have to try it. Okay. You have to try it. You have to allow yourself. You have to be patient with yourself. You know, loving yourself meaning you be patient with yourself. Okay. You are going to make mistakes. You sometimes don't know what word to use. But the sooner you get started practicing, the sooner you're going to get it. Okay. Your intuition is right. It passes the vertical line test. It also passes the horizontal line test. The question is, how do we say it using the language, right? You have to refer to the definition. Definition is the king, right? In a country, in some country, we have president, we have king, we have the king, the head of state. In mathematics, there's also the head of mathematics. What is the head of mathematics? Definition. Definition is a king. You always have to refer to it. When you're in calculus class, just remember this. All those definitions, you have to constantly reflect on them. One moment you don't, you're going to lose point. Okay, now it is 1-to-1. How do we say it? Right? So it's a to be case as it applies to this function, right? Then you reflect on this function's definition. Whenever, right, x1 is not, x1 is in, x1 is not equals to x2 in A. And what is A here? What's the domain here? The domain here will be specific because now you're not talking about any domain. You're talking about that specific domain for this particular function, right? Meaning x1 and x2 are greater than or equal to 0. They're in this domain. Whenever this is true, we take a square root of them. And they will not be the same. You just have to make sure that statement is true. This statement, I'm sorry. Is this statement true? When your professor watch this statement and she or he gonna think about, is this statement true? Because we're gonna make that judgment call. And this is true. You are making a statement. I'm making a statement here. If this statement is true, definition is fit, it is to be. Then you can say that is a one-to-one function. You see how once you get the hang of it, it's not hard, isn't it? But it takes time to get the hang of it. And this is something most people who, before they enter calculus class, they're not used to, including myself. By the way, I'm only speaking from my own experience. I wasn't used to it. Oh, what? I have to think about the words. I have to think about each word. And all of these words together, yes. Okay, so we have covered all 8 functions and with the concept. Okay, so we summarize today. We summarize and we made this table. Okay, we made this table. And now I want you guys to enter another column regarding whether this function is one-to-one or not. Okay, at the end of the class, I'm going to send you this table. You want that? I'm sure you probably want it, right?
Sure.
I'm going to send you this table. Okay. And you're going to create another column. But you want to watch, you want to really chew on the words. I assure you that the time and effort you make today to try to understand those words is not going to be in vain. It's going to ensure you to get lots of points. All right. So today's homework, okay. Of course, I'm going to spell out in the homework session, but mainly is please, please make sure you study the recording. On the day that I was out, but I made that recording and really study the lectures, really study the lectures. Okay, it wasn't hard, but you have to get your hand to do it. You have to get your hand to do it. Okay, get your paper pencil, really do it. And we're gonna keep doing this. So tomorrow we're gonna get to the other functions, right? From number 9, which is exponential function, logarithm functions. Okay, because basically I'm showing you the method. You don't have to remember a lot of things. You don't have to memorize. But you reason with me and you reason with yourself. And at the end, okay, you come back and tell me, hey, I don't have to remember anything because they're all reasonably, rationally connected. I can just figure it out on the spot. Isn't that what you wanted? Right? If that's what you wanted, that's where I'm leading you to. Okay, so study the recording and I want you guys to try. I want you guys to practice your algebraic skills. Okay, so this place I want you to practice is basic 33. Okay, in the neighborhood of basic 34A, right? You probably have seen that. Basic 34A, right? There's a neighbor, basic 33. basic 33. You say, oh, I know that. Or if you know that, great, show your work. Be able to do it. Because these basic skills, you may see them in Calc 2. Very basic. You could be, you're doing integration, and in the last step, you encounter something like this, and you need to be able to do it to get your final, 2-3 points. All right. I think that's all for today. And I will see you guys tomorrow. Thank you, Farouz.
You're welcome, Professor. This table is very precious, powerful. If you send it to a students, me included, I'm gonna refer to this table if students stop by to Math Study Center today from 3 to 6. Definitely organizing everything you taught us today. And visually, we can see why one function is one-to-one at the same time, the other next one is not, by putting together, and the one picture worth 1,000 words, so on and so forth.
Thank you. Yep. And make sure you graph each one of those. You graph each one of them, okay? It's very easy to do. I assure you, it's very easy to do, but it is also easy not to do. Okay, we're gonna refer to these tables often in the future, and you will need this table. You will need to know all these details when you're in calculus classes. Okay, all right, so without further ado, I will see you guys in office hours. If you're more than welcome to come, and see you soon. Thank you for coming.
Thank you, Professor. See you next class.
Good job.
Thank you, Professor.
Thank you.